Today we're going to talk about geometric sequences and series. A geometric sequence occurs when the ratio of consecutive terms is constant. We call that the common ratio, and we're going to always use the letter R to talk about that. And the graph of a geometric sequence, like arithmetic, will be discrete points, and it will follow an exponential pattern, but only when the common ratio is positive. So for example, if we want to determine whether or not the following sequences are geometric, we're going to check to see if we can multiply the same thing to go from one term to the next. So here we can multiply by 2, by 2, by 2. So yes, it is geometric and the common ratio is 2. In our next example, we can multiply by a fraction. So multiply by 1/5 times 1/5 times 1/5. Our common ratio is always thinking about multiplication. So if you're thinking that you want to divide, you should be multiplying by a fraction. So yes, this is also geometric and its common ratio is 1/5. Our next example, there isn't something that we can multiply from one term to get to the next. Even though we see a pattern, it is not geometric. Our fourth example, we can multiply by a negative number. That's how you get alternating signs when your common ratio is negative. So yes, it's geometric, and your common ratio is -3. So just like with arithmetic, we want to have a rule, an explicit rule, for being able to find the nth term of a geometric sequence. So the rule is the following. A sub n equals a sub 1 times r to the n minus 1. So just like with arithmetic, a sub n is representing the nth term, a sub 1 is the first term, r is the common ratio, and n, of course, is the number of the term. Be really careful when your r is negative, or if your r is a fraction. You really want to make sure that you put the r in parentheses. Okay, so you apply the power to the whole thing, whether it's a negative or a fraction. So if we want to check out a rule for finding the nth term here, we are going to take a look at, first of all, whether or not what our common ratio is. So here, if we take a look, our common ratio is going to be 1/3. Okay, so a sub n equals a sub 1 times r to the n minus 1. That is our common ratio. Okay, and we need to find a sub 10. So a sub 10 here, we're just going to plug in 6 times 1/3 to the n minus 1, or to the 9th power. That will give us, for a sub 10, 2 over 6,561. Okay, if you can, leave your answer as a fraction instead of a crazy decimal. That would be preferable. Number 2, if we look here, our common ratio is going to be -2. So as we set up our equation or our rule for the nth term, a sub n equals a sub 1, which is 10, times r to the n minus 1. Okay, so again, here is our rule, and then a sub 10 would be 10 times -2 to the 9th power, so a sub 10 would be -5,120. Okay, so those are our first two examples. Let's look at a couple more. So this one is just written out a little differently. Our first term is 12, so I know a sub 1 is 12. And each term is 4 times the previous term. That means that our common ratio is 4. So a sub n equals a sub 1 times r to the n minus 1. Simple enough. And then to find a sub 10, these are the same directions as with the other examples. So 12 times 4 to the 9th. So a sub 10, and again, you're just grabbing your calculators here. 3,145,728. There's your a sub 10. Our next example, we're giving you a sub 5 and r. So in order to write our equation for the nth term, we have to find a sub 1. So if we use our equation or our rule here, let's fill in what we know. A sub n is 32. I don't know a sub 1 this time. R is 2/3. And n, because I'm using a sub 5, is going to be 5. So this would be to the 4th power. So as we work this out, just use your calculators, raise 2/3 to the 4th power, and divide 32 by that value. So a sub 1 will end up being 162. And now we can write our equation. So our rule for the nth term is a sub n equals 162 times 2/3 to the n minus 1 power. And then again for a sub 10, we're just going to pop in n as 10. So 162 times 2/3 to the 9th power. And we're going to need a fraction here. 1,024 over 243. Okay, there's your a sub 10. We do have 2 more examples here, again, just to try to show you a little bit of everything that we can do. This time I'm giving you a sub 5 and a sub 6. Actually, I meant that to be a sub 3, otherwise that doesn't really make sense. So I'm going to change this here. This should be a sub 3. Sorry about that. That looks terrible. Let me just erase that. So a sub 3 is going to be 20. There we go. And a sub 6 is negative 160. Okay, so we did something similar to this when we were talking about arithmetic sequences. So let's picture, here's your 20, which is our a sub 3, a sub 4, a sub 5, a sub 6 is negative 160. So in order for us to find our equation, we need to find a sub 1, and we also need to find r. So I'm going to find r first. And I'm going to think of this as 20 times r to a certain number of times is going to have to give us negative 160. So if I start here at 20, I'm going to have to multiply by r here. I'm going to have to multiply by r again. I'm going to have to multiply by r again. That means I need to multiply by r 3 times, or 20 times r to the 3rd will give us that negative 160. So r to the 3rd is going to equal negative 8, which means r equals negative 2. So now that I know r, I can actually find my a sub 1. And to find a sub 1, we're just going to go back here and use our general formula. If a sub n equals a sub 1 times r to the n minus 1, I'm going to use the fact that a sub 3 was 20. So 20 equals a sub 1 times r, which was negative 2. And again, because I'm using a sub 3, n is 3, which means we're going to raise that to the 2nd power. A sub 1 will turn out to be 5. Okay? And now that I have a sub 1 is 5 and r is negative 2, we can write our equation. A sub n equals a sub 1 times r to the n minus 1. And we're still, of course, also looking for a sub 10. So a sub 10 equals 5 times negative 2 to the 9th, which again, using your calculators, a sub 10 is negative 2,560. Okay? All right, we have one more example here using our general rule, or our explicit formula. And it's worded this way, right? There's one geometric mean between 11 and 396, and I'm telling you that a sub 1 is 11. So all that means when it says there is one geometric mean between 2 numbers, it just means that if I take my first number, here's 11, one geometric mean, it means there's one term and the sequence is geometric between 11 and 396. If it said there were 2 geometric means, well, you would have just 2 terms in between 11 and 396. And then I also told you that a sub 1 is 11. So again, in order to find our rule for the nth term, I need a sub 1 and r. I have a sub 1, right? That's 11. So now I just need to find r. So if I take my 11, I have to multiply it by r once, twice, so r squared, to get 396. That means r squared equals 36. And so r technically equals plus or minus 6. So sometimes you have to pay attention as to whether or not you're just forming a sequence or if it's a particular value that you're finding here. If I'm telling you that a sub 1 is 11, in order to get a sub 3 to be positive 396, I can only have my r being positive 6. Otherwise, I would have the wrong sign. Okay, so you just have to kind of take a look at the sequence they've given you. So a sub n in this case would equal a sub 1, which is 11, times r, which is 6, to the n minus 1. And then a sub 10, of course, would be 11 times 6 to the 9th. And that would give us a humongous number here. That will give us, let's take a look here, 110,854,656. And that's our final answer there. Okay, so again, knowing that our odd values in our sequence here are positive, our r had to be positive. Because when you raise a number to an odd power, it's going to keep whatever sign it is. So if our r was negative, our sequence wouldn't match with what was given. Okay. All right. So let's move on here, away from just looking at sequences, and let's look at a series. Just like arithmetic, a series is going to just be the sum of a geometric sequence. And again, we're going to be looking here at either a finite geometric sequence or a partial sum. So our formula here, S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. I'm going to stress again, be careful when your r value is negative or a fraction. When that happens, I really do suggest putting your r in parentheses, okay? Because especially in the numerator where you're raising it to the power, you want to make sure that you're raising r to the power, okay? Whether if r is negative, the negative number needs to get raised to the power, and so on, okay? So keep that in mind. All right, how does this work, the sum? So find the sum of the first 6 terms of this sequence. So first we need to find our common ratio. So every time here we're multiplying by 3. So using our formula, again, write it down until you have it memorized. S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. We have everything we need. So we are finding S sub 6. Our a sub 1 is 21. Our r is 3, so I'm not going to put extra parentheses in. Our n is 6, whoops, and 1 minus 3 in the bottom. So use your calculator. I strongly recommend using the alpha y equals to input it in as a fraction. So S sub 6 would be 7,644. Okay. Similarly, with our next example, again, we need to find our r value here. So example 2. We can multiply by a half every time. So again, our r is going to be half here. So S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. We're looking for the first 10 terms now, so n is 10. Our a sub 1 is 4. 1 minus a half to the n over 1 minus a half. Right? You're welcome to use 0.5 for the half. If it makes it easier to type it in, that's totally your choice. Again, using your calculator, being very careful. S sub 10 is 1,023 over 128. Again, I would prefer you put it in as a fraction if you get a crazy decimal. If it doesn't convert easily, then we'll talk about rounding. But for now, try to convert it to a fraction. All right, let's look at a couple more here. So example 3, we're looking for the sum of the first 8 terms. Here, our r is going to be -3, and this is where you're going to have to be really careful in your formula. So s sub n equals a sub 1 times 1 minus r to the n over 1 minus r. We're looking for the first 8 terms, so s sub 8 equals a sub 1, which is 1, times 1 minus, and I mean it, put your r in parentheses here. You really want to make sure that you're taking -3 to the 8th power. These negatives do not cancel out, okay? Be really careful. And then 1 minus -3. So again, using your calculators carefully, you should get that s sub 8 will be, where am I here? -1,640. All right, last example here. We're looking at a sequence, and I'm asking you to find n this time, and I'm giving you the sum. Okay, so let's look at what we've got here. Here's our formula, right? S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. So we need, let's see, what do we need here? We have the sum, so we can fill that in right away. We have a sub 1. We even have r, right? Our r is going to be 2. So 1 minus 2, what we don't have is n. So 2 to the n over 1 minus 2. So from here, we're just going to simplify. I'm going to divide by 3 first. So 1,023 equals 1 minus 2 to the n. And our denominator, 1 minus 2, I'm going to simplify that right now also to -1. I'm now going to multiply both sides by -1. So -1,023 equals 1 minus 2 to the n. I can subtract 1 from both sides. -1,024 equals -2 to the n. We're getting closer, almost done. Divide by -1. 1,024 equals 2 to the n. Okay, now, at this point, if you want to use your calculator and just try guessing and checking 2 to what power is 1,024, be my guess. But if you want to just work it out algebraically, if you remember, we talked about that you can use logs to help you if you'd like. Okay, so you can take the log of both sides here. The log of 1,024 equals the log of 2 to the n. If you remember our power rule, the n can come out front. So the log of 1,024 equals n times the log of 2. And now to get the n by itself, we can divide both sides by the log of 2. So the log of 1,024 over the log of 2 equals n equals 10. Okay, remember, n is the number of the term. So n can never be negative, it cannot be a fraction, and it's not going to be 0. Okay, so if you get one of those values, you just want to double check and make sure that you didn't make any mistakes. And that wraps it up. See you guys soon.